Hello everyone, welcome to today's sharing. I'm Sam from the Liashili Intelligent Maintenance Service team. This is episode 12 of series 2, the final episode of this series. The previous 11 episodes covered hardware maintenance from mechanical to electrical to fire protection. Today we move to the software layer, data consistency between WMS and WCS. The WMS, the warehouse management system, handles inventory and inbound-outbound documents. The WCS, the warehouse control system, schedules the stackers, conveyors, and other equipment to execute tasks. What happens when the data between these two systems disagrees? Inventory won't reconcile. Tasks get stuck. Document statuses go abnormal. All sorts of odd problems crop up. Today we cover how to troubleshoot them. 4 learning goals today. First, understand the division of labor between WMS and WCS, what each manages and how they interact. Second, master the common inconsistency types. Third, learn to check data consistency with standard methods. Fourth, master troubleshooting for stuck tasks, document exceptions, and other common problems. This may look like software territory, but as a maintenance engineer, system-level troubleshooting is a must-have skill. Take it seriously. Simply put, WMS manages inventory. WCS manages devices. That is, the WMS knows what goods are in your warehouse and where. The WCS knows how to make the stacker fetch them. For example, the WMS issues an order. Say, put pallet A in location B, and the WCS breaks it into a series of subtasks: travel, hoist, fork, and so on. When done, the WCS reports the status back to the WMS, which updates the inventory. How exactly do WMS and WCS connect? 3 ways: middle table, API, and MQ, which we'll cover in detail on the next page. Understanding the architecture is essential for troubleshooting data inconsistencies. WMS and WCS connect in 3 main ways. Let's take them one by one. On the left, the database middle table. The WMS writes tasks to a shared table. The WCS pulls it on a timer, then writes results back. The advantage is simplicity and loose coupling, good for batch data. The drawback? There's a sync delay, and under a surge the table backs up. In the middle, API's web service. The WMS calls the WCS API directly to issue commands in real time, with millisecond response and clear status. But note, it depends on network connectivity. If the network drops, the task drops. On the right, the MQ message queue, asynchronous messaging via middleware like RabbitMQ, Redis, or Kafka, fully decoupling the systems, with high reliability and surge resistance, suited to high concurrency scenarios. Each has pros and cons, and real projects often mix them by scenario. Understanding these helps a lot when troubleshooting communication faults. There are 5 main inconsistency types. Stock quantity mismatch is the most common. For example, WMS shows stock but the location is actually empty. Or the reverse. Location status mismatch affects inbound slotting. WMS thinks a slot is free but WCS says it's occupied. Task status mismatch. WMS considers a task done while WCS is still executing it. Document status anomaly. An in-out document stuck open and can't be closed. Device status mismatch. WCS shows a device online but WMS says offline. Each type has a different handling method which we'll detail later. Once a data check finds an inventory discrepancy, handle it by the standard process. Step 1. Identify it. Step 2. Verify physically on site. Step 3. Analyze the root cause. Interrupted task. Comms fault or human error. Step 4. Correct it in the system. Step 5. Log and file it. On the right is cycle counting. Frequency by ABC class. How is the frequency set? A class high turnover items weekly. B class monthly. C class quarterly. The count process runs from system-generated tasks through PDA scanning to handling the discrepancy report. Small discrepancies auto-correct. Large ones need manual review. Master this process to resolve inventory discrepancies quickly. There are 5 consistency check methods: stock reconciliation, export, and fully compare the WMS and WCS stock reports monthly. Location status patrol. Automated weekly. Task closure check. Daily. Find tasks the WCS marked done, but the WMS left open and handle each. Interface monitoring. Watch sync delay and data backlog in real time. Cycle counting. Randomly scan locations on site and compare to WM. Common tools include the WMS's built-in data validation, the WCS task monitor screen, a database query tool, log analysis, Excel comparison, and the counting PDA. You should be comfortable with all of these. Daily inspection is key to preventing problems. Each shift, check the comms status and task completion rate, whether interface data is backing up, whether the system log shows errors, and that the services are running. Weekly, do stock reconciliation and location status checks. Monthly, do a full count, a performance review, and log backup. On the right are common operations. For instance, restarting the WCS service has steps. First, ask operators to pause new tasks, wait for running tasks to finish, then restart, then confirm recovery. Always back up before clearing backlog data. That's important. To check service status, use services.msc on Windows and system call status on Linux. Maintenance engineers should be fluent in these operations. Troubleshooting a stuck task takes 4 steps. 1. Check the WCS task queue to find the stuck task. 2. Analyze the cause. A device fault that interrupted the task, a comms timeout, or a location detection error. 3. Intervene. Force in the stuck task, reset its status, and restart the WCS service if needed. 4. Verify recovery. Reissue a test task to confirm normal operation. Document exceptions are handled similarly. First, compare the WMS document status against the WCS task status, then check the interface communication records and logs. Handling includes a manual force close, retriggering the sync, and recomputing inventory. An important reminder, every manual document fix must leave a record, who fixed what, and when, all written down clearly. Troubleshooting comms loss takes 4 steps. 1. Check the network. Ping to see whether the WMS and WCS servers can reach each other. 2. Check the services. Are the WMS and WCS services running? 3. Check the interface. Is there a large data backlog? 4. Recover the data. After commas return, let it auto-resend, then do a full reconciliation. Daily prevention matters even more. Set up monitoring alarms. Alarm if comms are down over 5 minutes, if the backlog exceeds a threshold, or if a task is stuck over 30 minutes. Daily, check the comm status and task completion rate. Quarterly, restart the WCS service and clear the backlog. Log analysis is a fundamental troubleshooting skill. On the left, a log overview, with the WMS and WCS log locations, types and level definitions. Info is normal, warn needs attention but isn't urgent. Error and fatal need immediate action. Usually start with error level entries. On the right, common error patterns and their meaning. A communication timeout is usually a network issue. A task failure means the device is offline or there's a conflict. A data sync error means checking the middle table. And a service exception may be resource exhaustion. Knowing these lets you locate problems fast. Use tail-2 to monitor logs live, so you see issues the moment they appear. The disaster recovery plan is the last line of defense in system operations. On the left, the backup strategy, a full backup early Sunday kept for 4 weeks, a daily differential kept for 7 days, and a log backup every 4 hours, for point-in-time recovery. Remember, always do a restore test of your backups. On the right, the recovery steps. Step 1, restore the database in order. Full, then differential, then logs. Step 2, start services in order. WMS first, then the middle table, then WCS. Step 3, verify the interface. Confirm comms and task execution. Step 4, verify the data with a full reconciliation. Post this procedure in the server room or in the ops manual so that when something goes wrong, you follow the steps calmly. Here's a case of interface data backlog. One morning, a warehouse found no in-out tasks executing, and the investigation found over 50,000 rows piled up in the middle table. What happened? The WMS kept writing new tasks, but the sync process had hung, so the WCS couldn't read any of them. Clearing the table and restarting the sync service fixed it. What does this teach us? Interface data monitoring is crucial. With a backlog alarm that night, it could have been cleared in the small hours without affecting daytime production. So set up an alarm on interface data and notify maintenance the moment the volume exceeds a threshold. Let's recap today's 6 key points. 1. WMS manages stock and WCS manages devices. Understanding the split is the basis for correct troubleshooting. 2. The 5 inconsistency types each have their own handling. 3. Interface data monitoring is key. A backlog alarm lets you fix problems before they hit production. 4. Troubleshoot a stuck task in 4 steps. 5. Do a full reconciliation after comms loss. 6. Run a system of inspections and alarms. Got all 6? And that completes all 12 episodes of Series 2. Gidoo? We started from the AS/S foundations and went through rails, wire rope, and chain, the addressing system, the telescopic forks, the RGV, the servo drive, the I/O station, early accuracy signals, safety inspection, fire interlock, and finally, WMS/1 of SARO. Thank you for following along the whole way. See you in Series 3 on AGV maintenance. Now finally, let me share something serious with everyone, which is also a bit of an ad for our team. Lay Chile Vietnam team specializes in logistics automation equipment maintenance for Vietnamese companies. We are a local team with prompt response and solid technical skills. Feel free to contact us anytime you have needs.